Hi folks, we're going to take a look at page 419, number 14. So they give us two unit vectors A and B, and they tell us that the magnitude of the sum is equal to root 3, and then they want us to determine the value of this expression here. Okay, so I'd say the first thing to do here is to expand this expression and see what we can get. So if we take that expression, so again we can distribute this like we do two binomials, okay, just with the dot product. So here we've got 2a dot b, okay, then we've got plus 6a dot a, okay, then we've got minus 5b dot b, and then we've got minus 15b dot a. Okay, so now a couple of things here. First of all, we know that the dot product is commutative, so a dot b and b dot a are have the same value, so this can just be written as negative 13a dot b. Okay, and we know that a vector dotted with itself is just the magnitude of that vector squared. Same thing here, 5 times magnitude of b squared. Okay, a and b are both unit vectors, so these expressions are both equal to 1, so we just have 6 minus 5. So you have negative 13a dot b, okay, plus 1. Okay, and that's about as far as we can go, knowing what we know about these vectors. Okay, but somehow we have to use this given piece of information to help us determine a dot b. Okay, and I'm going to show you two ways to do this. So again, think about which way you feel more comfortable using. So there's a more geometric way of doing it. So option 1 is to use the fact that you know how to draw the angle between two vectors. Okay, so here if this is a and b, both have magnitude of 1, and you're adding a plus b, okay, that's what the sum would look like. So here this is root 3, and you can find this angle in that triangle. Of course, this does not represent the angle between the vectors, but its supplementary angle will. Okay, so here, again, at this point here, we've done this so many times, theta will be equal to cos inverse of, well, that's the opposite side, so it'll be root 3 squared, so 3 minus 1 squared, minus 1 squared, so minus 1, all over negative 2 times, again, the length of the other two sides. Okay, and what we have here is, well, actually we have cos inverse of 3 minus 2 is 1 over 2, negative 2, so negative 1/2, okay, and cos inverse of negative 1/2, okay, you can check it with your calculator, but we've done this many times, is 120, okay, and of course the angle we're looking for is the supplementary angle, which is 60 degrees. So that's the angle between the vectors, and so from there we can finish off that expression. So negative 13 times the magnitude of A and the magnitude of B, both equal to 1, times cosine of 60, okay, plus 1, and that's just, cosine of 60 is just 1/2, so we have negative 13 over 2 plus 1, so that's just equal to negative 11 over 2. Okay, and there's our answer. Okay, the other option is, I guess, to take a more algebraic approach. Okay, so option number 2, if you like this one better, is to take this expression magnitude of a plus b and square it. Okay, and you'll see why I do that in a second. So if I take magnitude of a plus b and I square it, that's equal to, well, the square of root 3 is just 3. And now I can use the fact that this can be written as a dot product, can be written as a plus b dot a plus b. Okay, that's equal to root 3. And hopefully you're seeing what's coming here, that when I now expand this, I have a dot a. Okay, I have a dot b plus b dot a, but since those are the same, that's just plus 2a dot b, okay, and then plus b dot b equal to 3, but of course a dot a is just the magnitude of a squared, So this is just equal to 1. B dot B is again just equal to the magnitude of B squared, so that's just 1. 1 squared equals 3. So A dot B is just equal to 3 minus 2, 1 over 2, 1/2, okay, which is exactly what we found earlier, doing it geometrically. So in the end, we get, finish this off, that's just equal to negative 13 times 1/2 plus 1. So here we've got negative 13 over 2 plus 1, which is equal to negative 11 over 2. Okay, there you go. So just to recap, okay, when you want to simplify an expression like this, first thing is to expand it, to write it into combinations of simpler parts, and then use the information that's given. And here we use the fact that A and B were unit vectors to simplify, and we use this information to determine the dot product of A dot B, either geometrically or from a more analytical perspective using properties.